everyone. Today we're going to talk about sequences. This is the beginning of a new unit for us. So when you do these notes, they will go in a different section of your binder. All right, so let's talk about what a sequence is first. A sequence is come on, pen. There we go. A set of numbers with a particular order or pattern. Okay, and then each number is called a term. And you can write that on here if you have room. Each number is called a term. Out of room. Okay. Next, we have a finite sequence and an infinite sequence. A finite sequence is a sequence with a limited number of terms. Okay, so if I were going to list out a finite sequence, I could just say 1, 2, 3, 4. Okay, so then an infinite sequence is a sequence with an unlimited number of terms. So it's going to look very similar if I do 1, 2, 3, 4, and then I go dot, dot, dot. It means it keeps going in that same pattern for forever. Okay? The first term in a sequence is denoted A sub 1. That 1 is a subscript, which means it is not the same size. So I'm not writing A with a 1 next to it. That's not what I'm doing. I'm writing A with a little 1. Okay? Each subsequent term is denoted A n, where n is the term number in the sequence. All right, so if I were to look at this, this says A sub 1. A sub 1 means the first term, so our first term is 1, because that's the first number. The next one says A sub 4, so 1, 2, 3, 4. So A sub 4 would be 13. The next thing he wants to know is A sub 9, though, but I only have 5, so that means I need to find the pattern. So if I'm looking at this, I went from 1, 5, 9, 13, 17. It looks like I'm adding 4 each time. So my next one would be 21. And then 25, 29, and then 33. So the ninth term is 33. It wants a few more, so I'll 37 would be the next one. 41, and then 45. So again, that's 5, 6, 7, 8, 9, 10, 11, 12. So the 12th term is 45. Since each term value is paired with exactly one term number, a sequence is a function of the following properties. The domain is the set of term numbers, and then the range is the set of term values. In an infinite set, the domain is the set of natural numbers. Also known as counting numbers. Okay, so then we're going to talk about two different ways to find formulas. The first way is what's called a recursive formula. A recursive formula is a rule in which one or more previous terms are used to find the next term. Okay, so we have what's called a Fibonacci sequence. The Fibonacci sequence goes 0, 1, 1, 2, 3, 5, 8, 13, and so on. Okay, in this sequence, our first term is 0 and our second term is 1. And then for every term after that, what we do, so we say an, so that would be our next term, is equal to the previous term, so an minus 1, plus the term before that. Oh, 2. Okay, so an means our next term, in this case for recursive, is going to be the previous term plus its previous term. Alright, so it says A1 is 14, AN is the previous term, so you might write that down somewhere. AN minus 1 means previous term. Okay, AN minus 1 plus 9. Alright, so it says find the first 5 terms. Well, it gave us the first one. The first one is 14. And then we're going to add 9 to that. So that would be 23. And then I'm going to add 9 to that. That would be 32. And then I'm going to add 9, so 41. And then add 9, it would be 50. And I just need to find the first 5. Okay, A1 is 6, so our first term is 6. We'll find the next term by doing 2 times our previous minus 5. Alright, so our first term is 6. I'm going to do 2 times that, so 2 times 6, which is 12, minus 5. So 12 minus 5 is 7. Then I'm going to do 2 times 7, which is 14, minus 5, which is 9. Okay, I'm going to do 2 times 9, which is 18, minus 5, which is 13. 2 times 13, which is 26. 26 minus 5, which is Sorry, I was yawning. 21. Alrighty. Goodness. Alright, so our first term is 354. We're going to add 6 and then divide by 3. Okay, so 354 plus 6 would be 360. Divided by 3 would be 120. 120 plus 6 is 126. Divided by 3 is 42. 42 plus 6 is 48. Divided by 3 is 16. 16 plus 6 is 22. And it doesn't divide by 3 evenly. So I'm going to leave it as 22 over 3. Okay, first term is 3. Second term is 4. And we're going to, this says multiply the 2 previous terms. So in this case, I'm going to do 3 times 4. 3 times 4 is 12. The next thing I'm going to do, so that was 3 and 4. Now I'm going to do 4 times 12. 4 times 12 is 48. And then I'm going to do 12 times 48. 12 times 48 is 576. Alright, so this says write a rule for each sequence, then give the next 3 terms. Sometimes you kind of have to play with these a little bit to find a good formula. So we have 4, 11, 32, 95, 284. Okay, so I'm just going to kind of look and see what's happening. So from 4 to 11, I added 7. Here I added 21. And then 63. I'm not even worried about that. Notice what's happening here. This is multiplying by 3 each time. Okay, so I could say, I always have to list out my first term. So my first term is 4. And then I'm going to say my next term is going to be 3, from this right here, 3 times my previous term. I would have to see what I need to add. And I like to use the first term to see what would have to happen. So 3 times 4 is 12. But I need it to be 11. So minus 1. And I could make sure that works with the next one. 11 times 3 is 33. Minus 1 is 32. And you could check it with each one to kind of see if it's working or not. Okay, let's look at the next one. I'm going to erase this so I have some room. Okay, I have 100. I have 60, 40, 30, 25. Okay, from here to here, we went down 40, and then down 20, and then down 10, and then down 5. Notice what's happening on each of these. I am halving each of these. Okay, so again, I always have to list my first term. So this will be 100. And my next term is going to be half of my previous term. So half of 100 is 50. And how could I get that to 60? I would have to add 10. I could double check. Half of 60 is 30. 30 plus 10 is 40. Half of 40 is 20. Plus 10 is 30. So I'm just kind of trying to find that pattern. Recursive formulas, I feel like, are a little bit more difficult to find. I think the explicit one is, in my opinion, a little better, but everybody has their own preference. So an explicit formula is a rule in which the nth term is defined as a function of n. So it says find the first 5 terms in the sequence. On an explicit formula, so notice it doesn't have the a n minus 1, okay? This is for recursive. Oh, not writing very well. Okay, for explicit, what I'm going to do is I'm just going to plug in this case it says 5 terms, so the number is 1 through 5. So I'm going to do 7 times 1 minus 3, which is negative 14, sorry. And then I'm going to do 7 times 2 minus 3, which is negative 7. 7 times 3 minus 3, which is 0. 7 times 4 minus 3, which is 7. And 7 times 5 minus 3, which is 14. And then I will write them out. Negative 14, negative 7, 0, 7, 14. If you don't write them out, I will not count off for it. Just make sure they're in order up here. Negative 14, negative 7, 0, 7, 14. Okay, you can also use your calculator. So like number 8, I know when y'all see fractions, you kind of freak out. So 1/3 to the n plus 1. I can use my calculator to help with this. Second plus 712. Okay, so what I'm going to do is I'm going to go to y equals, and I'm going to type in that formula. So parentheses, I like to use the alpha, y equals enter, 1/3, close parenthesis, caret, and then here it said n, is it plus 1 or minus 1? Plus 1. Okay, we're just going to put x for now. So we're going to put x and then plus 1. What I can do is I can hit second and then this button right here that says graph or table. And I'm not looking at 0, I'm looking at 1. 1, 2, 3, 4, 5. Those are my first 5 terms, as long as I start at 1. Okay, so 1 night, 1 over 27, 1 over 81, 1 over 243, and then 1 over 729. So I could use my calculator to help me find those when it's an explicit formula, okay? it does have to be explicit. So that was 1 over 1 over 9, 1 over 27, 1 over 81, 1 over 243. What? My pen is not wanting to work today. 1 over 243, and then 1 over 729. Okay, so you could do it again. Negative 4n squared. I'm going to y equals. I'm going to clear all that out. And I'm going to type negative 4, and I'm going to put x squared. Second table. And I have to make sure I'm starting at 1, and it just wants those first 5 terms. So 1, 2, 3, 4, 5. Okay, so that would be negative 4, negative 16, negative 36, negative 64, negative 100. Okay, and you could do the same thing. So I suggest for these next few, 10, 11, and 12, go ahead, put them in your calculator, find the first 5 terms, and then check to make sure you get the same thing. So on number 10, you should get 12, 28, 48, 72, and then 100. On number 11, you should get 1, negative 2, positive 4, negative 8, positive 16. And then on number 12, you should get 9, 4, 0, nope, 9, 4, 1, 1, 0, 1. Okay, so this next one says, write a rule for each sequence. Then give the next 3 terms. Alright, so negative 7, negative 9, negative 11, negative 3, negative 15. If you notice, those are going down 2 each time. Okay, so I'm subtracting 2 each time. We could kind of think of this as like a linear function. So the way that we would find our rule, it's kind of easier to go ahead and find those next 3 real fast. So my next 3 would be negative 17, negative 19, negative 21. And then we could talk about our rule for just a second here. Okay, my rule on this is going to be, and we'll have better rules later when we start splitting these up, but this is linear, so I can think about it as linear. So this would be negative, oh my goodness, I'm going to have an equals. This particular one, since I'm just subtracting the same number each time, I'm going to say negative 2n, and then I'm going to go the opposite way for just a second. The opposite of subtracting 2 would be to add 2, so this would be minus 5. Okay, and that's because you can do that like that as long as you're either adding the same thing each time or subtracting the same thing each time. Okay, on here, number 14, this is going up 3, up 5, up 7, up 9. So it does have a pattern here, but it's not the same until that second time. Now notice here, I'm adding 2 each time. Whereas here, these were always subtracting 2. Okay, so when it has 2 rows like this before you get a repeating number, this means that you're dealing with a squared term. So we're going to say an equals n squared. And then we'd have to figure out what we need to do. This is my first term. So if I look at that, my first term is 1. So 1 squared is 1, but I need it to be 3. So that would be plus 2. And I can double check that. This is my second term. So 2 squared is 4, plus 2 is 6. 3 squared is 9, plus 2 is 11. Okay, and so then I can find those next 3 terms. So 1, 2, 3, 4, 5. I'm looking for 6, 7, and 8. So I'm going to do 6 squared, which is 36, plus 2, which is 38. Okay, and then I'm going to do 49 plus 2, which is 51, and 64 plus 2, which is 66. On 15, we have 2, 5 over 2, 3 over 2, 7 over 2, and 4 over 2. Anytime I see fractions, I like to rewrite these so they all have a common denominator. So I'm going to rewrite this for just a second as this would be 4 over 2, because 4 divided by 2 is 2, and leave that as 5 over 2. This would be 6 over 2, and now it's a little bit easier to see that pattern, 7 over 2. And then this 4 would be 8 over 2. Okay, so now I can see that whatever I'm doing, I am dividing by 2. Okay, but notice this starts at 4, so this would be n, which is, this is my first term, and I would have to add 3 to it. Okay, and then I could go ahead and find those next ones. That would be 9 over 2, which doesn't simplify. The next would be 10 over 2, which is just 5, and then 11 over 2. So those are the 3 terms. Okay, 1, square root of 2, square root of 3, 2, square root of 5. Same thing. This would be the square root of 1, because the square root of 1 is 1. This is the square root of 2, the square root of 3, and then this next one is the square root of 4, because the square root of 4 is 2. That makes it a little bit easier to see our pattern here. So our pattern here for this is just the square root of our number. So that means to find my next 3, this would be the square root of 6, the square root of 7, square root of 8. Now, some people might want you to simplify this because they simplified the 4, which you could simplify like we have in the past. And we're going to stop there for today. So, yep, so this is a new section. Hopefully it's not too crazy, maybe a little bit, but I think you'll do just fine with it. I hope you have a great rest of your day, ladies and gentlemen.